Awesome. Well, welcome everybody. We'll go ahead and get started. It looks like everybody on our side is here as well. And so we have a great virtual tour for you today. We're really excited that you're here. And here's a quick overview of what we'll be doing for this morning. We've got an overview. We're going to talk a little bit about plant breeding and GMOs. A little bit of CRISPR, I think, is in there as well. We're going to tour the greenhouse and the automation space as well today. So as I mentioned, if you have questions throughout, feel free to drop them in the chat and we will make sure that we get to all those questions. Before I get going too far into introductions, I just want to make sure that I put up our forward-looking statements. And essentially what that means, this is a legal statement that just says, hey, we're not asking any of you out there to buy any Bayer stock or do anything based on what we're saying today. We're here just for information purposes only. So my name is Stephanie Bowe. I am our engagement lead here at Bayer Marana. I've been here about 4 years, so have had the privilege of watching this site go from essentially dirt to full production. It's been quite a ride. And also joining me today is Dr. April Carroll, who is our regional digital strategy lead. There she is. And Ryan Teller, who is our automation engineering lead, and he's going to take us through automation as well. And then we have the amazing Marissa Labarsky, who is going to be in a greenhouse for us today and going to talk about the climate in there. And each one of our team members will spend a little time talking about their career as they go through as well. So I'm going to do that really quick. We definitely wanted to share with you a little bit about our careers just because, I think it's so interesting to hear from people who have been in the industries for kind of a long time and see that journey to get there, right? So I am actually a broadcast journalist by trade. I was in television news for about 20 years and then decided that I wanted to do something different and went into education. So I was actually the head of PR for a local school district for about 2.5, 3 years. And then this opportunity it was Monsanto at the time, came up. And over that time period, the last 4 years that I mentioned, we became Bayer. We were purchased. And again, I've learned everything about agriculture on the job, which is something that I think a lot of people who are starting off, trying to decide what they want to do with their life, is to really understand that we don't expect you to come in and know everything, right? It's a learning journey. And I really appreciated that Monsanto and Bayer took a leap on someone like me and helped me learn all about agriculture through this time period, because I really love to share about agriculture with people, and that's my main job, and helping people understand just where we are with agriculture and how we need people like you to help us get to where we need to be. And I'm going to talk a little bit about that. I'm also a mom of 3 teenagers. So I've got 2 sophomores, they're twins. And then my son graduated last year. So this is his first year in community college and he's figuring out what he wants to do with his life. Right now, he thinks a biology teacher is what he wants to do. So anyway, we'll get started here with a quick overview of the site and then we'll toss it off to our experts. So I wanted to make sure to show you what we look like from above, and that's behind me and also on the screen here, because we're huge. We're 7 acres of greenhouse space, and it's super cool to drive by and see how big we are. We often forget how cool it is because we work here every day, and so we kind of forget. We work at this amazing place. So we're at the corner of Sanders and Twin Peaks, down the road from you, down the I-10.
Stephanie, can I bet in
Sure.
just a second?
Sure.
So an acre is roughly the size of a football field, kind of like the 5-yard line and 5-yard line. So they've got 7 football fields under greenhouse glass, right? So you guys know how big ours is, right? And our greenhouse is a lot of management, a lot of stuff to fix all the time. And they've got 7 football fields under glass, right? Okay? All right, go ahead.
Yeah, absolutely. It's a big job and takes a lot of people. So we're near Marana High School. If you've ever been down this way, maybe for a football game or something like that. We're also about 24 miles from the University of Arizona. And if we go the other way, we're about 100 miles from you in the Phoenix, Tempe area. And then we wanted to call out too that we do have some other sites in the state of Arizona. So up in Eloy, which would be basically between you and us, we do cotton. And then in Yuma, we're working on wheat and vegetables as well. So Bayer is in all parts of the state here and doing agriculture. And a lot of people will ask us when we say we work for Bayer, they'll say, like Bayer aspirin? And the answer is absolutely yes. Bayer aspirin is our flagship. That is the thing that our company started with. But we do have three areas of business with our company. So we're crop science. We also have pharmaceuticals and then consumer health, which is where that Bayer aspirin would be. So maybe, someone in your life is on Bayer aspirin daily for heart issues potentially. But also if you take Claritin every morning for your allergies, that's also a Bayer product. So this is a photo of what I like to call our modern farmers here at the site. Ironically, this photo was the last group photo that we have together because this was March 3rd of 2020. And then of course, we had our ribbon cutting on March 4th, the very next day. And by that next week, we all saw our world drastically changed. So we're actually double this size. We have about 150 people on site today, and we've done that through a pandemic, which you'll see Marissa and Ryan, when they're in the different spaces, will have masks on for their safety. But these are the different kinds of employees we have on site, people who are like Ryan doing engineering, like April doing data, like me kind of just being creative and storytelling. And so it takes a lot of different people to do agriculture. It's not just that sort of stereotype of a guy in overalls in a field. That is not what agriculture is anymore, and hasn't been for a really long time, if we're being honest. So why are we growing corn inside a greenhouse and so many other kinds of agriculture is being done inside now? Part of that is this mega trend we're seeing, and it's been being called out for quite a long time, that there will be 2.2 billion with a B more people on this planet by 2050, which is just 29 years from now, almost coming up on 28 years from now. And that is a lot of people, and we actually are going to need 50% more food and feed to feed all of the people. So while in the US, many of us are maybe not eating as much meat as we used to, we're maybe going, meatless Monday or trying out vegan. In lots of the developing world, they're actually eating meat and proteins for the first time, and that continues to be a trend. And so we'll need that food, that extra food, to feed all of those animals that are feeding people. And so we really need to make sure we have a secure food supply. That's what we're here helping with. Also, climate change. I don't even know if I have to go too in depth on that, because I think we all are very aware of climate change issues. And that's leading to losses for our farmers. Just 2 summers ago, a huge storm came through the Midwest and knocked down acres and acres and acres of corn. So it's happening in the US, it's happening all over the world. And pressures on those ecosystems, it's a really important thing that we innovate for that, but also it's the right thing to do for our world. So these are some photos from my grocery store just back in March of 2020. And, we went into the meat aisle, and most of the meat was gone at that time. There were supply chain issues. There are still supply chain issues. If you've gone into Costco anytime in the last couple of weeks, you may have noticed there's no toilet paper and paper towels again. And so this is going to be the norm if we don't make significant changes in the way we do agriculture. We will see supplies not be there when we want them. We didn't have tortillas and spaghetti, and that'll just be ongoing. And so that's your future. That's my grandchildren's future. And none of us want that. So how do we change that? It's by innovation. And really, innovation has been happening in agriculture for decades. And April's going to talk a little bit about that. But this just really shows in a really tangible way how corn is one of those areas where we have improved since the 1940s. So you can see the very long strip on the right there, that is how much it would take to get 10 bushel yield back in 1940. And we're getting down to 1,800 square feet to grow the same amount of corn. And so we're already innovating. We've been doing it. It's nothing new, but it needs to accelerate. And again, I feel like every one of you in that room there is part of the solution, and I hope that you choose agriculture for your future. So really quickly, just want to show before I toss over to April, just how sustainability is at the heart of what we're doing. We did say we have 7 acres of greenhouse space. And every time we do 7 acres, when we use 7 acres inside the greenhouse, we're actually replacing 190 acres out in a field. And a lot of the other innovations that we use here are helping to save other inputs like soil, water, and those kind of things. And so this just shows you, going from a field to inside the greenhouse really is saving just from the very get-go. All right, so that's my overview for you today. And then April, who I really should say is Dr. April Carroll, is here to talk about plant breeding and GMOs. And so this is the real story here of innovation. And take it away, Miss April.
All right. Thank you, Stephanie. Great introduction. So my name is April A.G. Carroll. I do have a PhD, but I like to be as normal of a person as possible. So I do have maybe just a little brief introduction about myself and my career that I can run through with you, if you would, Stephanie. So I did not start off wanting to become a plant biologist. I kind of happened into it by just going through a bunch of different things that I didn't like. And much like Stephanie's son in community college, that's where I started. I thought I was going to run the family business. I guess technically I still do, even though my family are retired now. But so, just eliminating things that I didn't like. I tried a lot of things, and I ended up with my bachelor's degree. Took me 7 years to get a 4-year degree. And the reason was that I actually had 3 majors. So I thought I was going to be a band instructor. I was a band kid, really loved music. And then I was going to run the family business, like I said. So I got another pretty far into a business administration major. But then I took a biology class, and I had finally a mentor that really got to me, that really understood me, and that really asked some tough questions about what do you want to do? Not do you want to run the family business, or I've only ever really done music, and what really gets your interests up. And so we started down a career path. And so I guess the 2 lessons that I would like to pass on here is find mentors who care about you and who want to help you become successful and satisfied in your life and your job. And then also to just try stuff. You're not trying to figure out what you want to be when you grow up. I still don't know. You want to try to figure out what you don't want to be, and then eventually you're going to find something that you really do enjoy, and that you really are passionate about, and hopefully it'll become apparent for you, just like it was for me. So meandered a lot. I worked for a big company, for DuPont. I worked at Purdue University. I worked at a startup growing baby lettuces in an abandoned steel factory outside of Newark, New Jersey. Flying drones in the field to try to understand how plants are growing, and then finally landing at this really amazing facility that Marissa and Ryan are going to tell you guys about today. So next slide, please, Stephanie. So with that, I became a plant biologist. What really piqued my interest about this was in the 1990s when there were a lot of talks about GMOs, and there was controversy back then. But really, I latched onto the science, and I started to try to understand, why is there controversy about this technology? To me, it seems like a miracle that's going to help feed the world. And I started to learn more and more about the biology, to the point that I understood, and I felt through my own research and talking with professors, that the GMOs were safe. And not only were they safe, but that I wanted to work on them and build them as part of a really sustainable program to feed, the extra billion people that we have, that are going to be coming into the planet in the next 28 and a half years. So it all starts, though, with the science of selective breeding. And so I found that when I start these conversations about selective breeding, if I start right away in plants, it's not so relatable. But if you think about dogs, so you've got all dogs, all domesticated dogs, are from a common ancestor in the gray wolf. They're pictured in the cartoon there in the middle. I have two descendants of that gray wolf sleeping under my desk right now. One of them is tiny and fluffy, and the other one's medium size and spotted. But they're both very different from each other, very, very different from that wolf. And I think what's really interesting about selective breeding, so it's all about natural selection selected for that wolf that is lean, very strong, agile, smart, pack mentality to work together, to hunt prey and to evade, other kinds of more dangerous either predators or other competing wolf packs. So as humans, we have taken the traits that we like in those wolves, like being lean, like being a part of a pack, and we've selected for the animals that then kind of meet our needs and selected out the traits like, chewing our faces off, treating us like a prey animal, so that we have a domesticated breed of dog that now sleeps under my desk and snuggles with me when I sit on the couch. So over generations, varieties and species are selected. And even in the last 100 years, you can see how much, more than 150 years, you can see how much even what we think of as breeds of dogs, how much we've changed those, even just in very recent history. So the English Bulldog in the 1800s was actually bred to fight bulls as a kind of a herding dog when bulls were actually used for sport in arenas of not just bullfighting, but also kind of a little bit more of a blood sport. And so those bulldogs were bred as working dogs. Now they're really a boutique dog. You can see the face got flatter, they got stockier, their legs got wider. Some of them have a real hard time breathing. They can't run very far, but very different than the working animal that was originally bred by humans. So we do this with dogs. We do this with all kinds of different plants. And so that's what I want to spend the rest of the time talking about today. So when we talk about new varieties, think about the Great Dane versus the little fluffy thing sleeping under my desk versus that gray wolf ancestor that they all came from. Okay, so humans selectively breed for different purposes, for companions, for work, things like that. So humans have been selectively breeding for plants without even knowing it for about 40,000 years ago, when we first were really selectively gathering plants. So this is way before agriculture, which was about 12,000 years ago, when we would go from forest to forest or glade to glade, and there would be, say, a stand of berries in a meadow as we were following a herd of, whatever, bison or mammoths or something, to that effect, but some pack of prey animals that we would hunt and then gather the berries and other vegetables and fruits from whatever area the prey animal pack was moving to. But that would be cyclical. So the tribe would come back to the same area year over year as it followed that herd through their migrations. And so by killing off the bushes of berries that tasted really bad or that made people sick and keeping the ones that were sweeter or that had some bigger, maybe easier to harvest berries, they were actually selectively breeding, and without knowing it, they were actually selecting for DNA. And so over time, we've gotten better and better at selecting for traits and characteristics, and in doing so, selecting for the DNA and kind of bringing that along with the traits that have solved problems for us. So we've gotten really good at breeding plants, and even better now that we understand the structure of DNA, we've gotten better at modifying plants. So next slide, Steph. So here's some examples just in the last, say 2,000 to 3,000 years of what we've been able to do with gradual advancements and improvements of vegetable varieties. So you can see even 350 years ago, this is modern history, folks. This is in Europe. This is an oil painting. 350 years ago, this was a delicacy. This was what watermelon looked like. So tons of seeds, tiny little bit of red flesh, that white flesh, was not very tasty, and it's kind of like what we think of as the rind where you eat down to. And watermelon today is this huge, beautiful fruit. You can see in the top picture, it's, you know, maybe the size of a handful of pears, but we've got this huge, beautiful fruit that's way too much even for the biggest summer barbecue party. So now we've began breeding our watermelon to get smaller again so that we have a personal size so that we don't have so much leftover watermelon. Same story though with corn. Its wild ancestor is called teosinte, just a few inches long. It's a grass. You and I would not walk past teosinte and say, that looks delicious. I'm going to start trying to breed that into something that I'm going to want to put butter and salt and maybe a little lime and what's that tahini spice that Stephanie loves. So really the foresight that our ancestors had in selecting these and breeding over many, many generations. Same with things like the mustard plant, which again doesn't even appear to be edible other than to grind up the seeds, and it is actually what our mustard that you would put on a hot dog comes from, grind up the seeds on that mustard plant. But if you actually selectively breed for clusters of flowers in mustard, you get a broccoli plant. And if you breed broccoli for immature flowers, you get a cauliflower plant. If you take mustard and you breed it for leaves, you get kale. If you breed it for roots, you get kohlrabi. So all of these things are actually all the same species. Kale, collard greens, cabbage, Brussels sprouts, all the same species. So I have an infographic on that, and I'd be happy to share that with the teachers if you guys would like to learn a little bit more about that. It's really a fantastic thing. But since we're time limited, let's move on to the next slide. Okay, so in this example, I want to share an analogy that Stephanie and a former colleague of ours worked on about how to kind of explain how we alter the blueprints or the final effects, the outcomes of our plants over time. So DNA is the blueprint, and plants are really built according to the plan, like you would build a house according to a plan from an actual blueprint or a CAD drawing. So by making minor changes, we can modify that blueprint and have a different outcome with your house. So you could enable a beneficial characteristic with gene editing. And so we're able to look at that DNA kind of how an architect would look at the blueprints for a house. So you find that specific stretch of DNA within the blueprint that's responsible for an important function like drought tolerance, disease tolerance, or flavor. And then we can make targeted changes to those blueprints to improve. So examples here would be to enable desired characteristics such as a drought tolerance, or you could deactivate something that's unfavorable. So if you have a plant that's really sensitive to a disease or a virus. Also, separately, you could even combine the most desirable combinations of a trait so that would generate varieties with the most beneficial and desirable end product like disease resistance and drought sensitivity together. So it's important, though, to remember that relative to the size and the complexity of the genome, these changes are small and really precise, like adding a kitchen cabinet or moving a wall 1 inch to the left. So the house as a whole will still stand as though it would have before, but with that one target improvement having been made. So at the end of the day, if you make an incremental change to that blueprint, it's really, your home is still a home. So the plant is still a plant, and it still has all of the original characteristics and the nutrition and the health that it had. But there are modifications now that we've gotten much better at being more precise than when we were hunting and gathering, or even in early farming when we were selecting for characteristics and modifying the DNA of those plants that we selected. Okay, next one, Steph. So this is an infographic from the International Seed Federation, just talking about kind of how we've improved our breeding methods over time. So early on with crop domestication, so like I said, hunter-gatherers were modifying 40,000 years ago. We first started to domesticate crops about 10,000 BC. So about 12,000 years ago, with the first domestic crop that we can best surmise that first domesticated crop was probably wheat. But then we got better and better at crossbreeding. And once we started to understand how genes were inherited with the famous monk Gregor Mendel crossing pea plants and understanding how single genes are transferred and how inheritance works. Okay, so then we moved on to other methods. Again, I won't go into too much detail, but finally we ended up at in the 1990s with the first launch of GMO, or genetically modified organisms. And so usually, let's see, so the technology came about in the 1970s, but it made it possible to insert a desired trait into a plant. So this is what genetic engineering or genetic modification in the agricultural definition. So if you compare a plant to a smartphone, genetic engineering is like uploading an additional app. So just as the smartphone is still the same, after you've added the additional app, the GM plant is still the same plant, but it's able to do more. So then in the later generations here, gene editing technologies are helping us to leverage better, more productive crops. So they build on what we've been doing for years as plant scientists and breeders and allow us to get to the same endpoint more precisely than the traditional methods. And so we're really trying to work with the genetic makeup of the plant's own families or species to be able to address some unmet needs of the consumers via nutrition, or of farmers and those end users, consumers. And you can tell I work in software because I just called people who eat food end users. It's been a long time. Okay, all right, Stephanie, next slide. So I'm going to skip this one, just again in interest of time, but we can maybe go here to the next slide. So plant biotechnology, or GMOs, as well as genome editing and even plant breeding, helps us to mitigate threats from things that could wipe out an entire crop. It helps us to reduce the amount of pesticides that we use, so having a more sustainable, more targeted delivery of pesticides. And able to decrease CO2 emissions by having to use less tractors, less farm implements. But one of the big questions that we get about GMOs a lot is, are they safe? And so I've been a plant scientist for 25 years. I have studied, I can't say, I don't know that there's anything that it could have fascinated me more than plant biology and plant molecular biology and genetics. And so I eat GMO food. I feed GMO food to my wonderful 8-year-old little boy who I love more than the moon and stars, because I believe, based on the research and the real big data point that maybe you guys might want to think about, is that over the last 20 years, we've had more than 1,000, it's actually more like 1,200 now, academic studies. Governmental bodies, more than 30 different governmental bodies have supported that GMO crops are just as safe as those developed through traditional breeding. And there was one study about 5 years ago in, I believe it was Time magazine, where they cataloged all of these studies and they counted up the number of data points, and it's actually 1 trillion. So not a million, not a billion, but a thousand million. So 1 trillion data points of GMOs being ingested by animals and by people, and there's not a single shred of evidence that these cause harm to the people that eat them. So I'd be happy to go way more into detail, but we will be here all day. So with that, I'm going to take my allotted time and just talk a little bit, one last slide, about the crops that are currently GMOs in the US. So if this was more of a Q&A session, I would ask you guys, what do you think? Which of these are GMOs? And everybody would raise their hand and say, I think it's corn. And I'd say, you're right. And it's cotton and it's sugar beets. All of these things now are sold as GMOs with very rigorous safety evaluations by the United States Department of Agriculture and the Food and Drug Association. So we have genetically modified sugar beets. and the wonderful Pink Glow Pineapple by Dole, which is now selling for $29. And if I could find one, it's one of those things where shut up and take my money. I want to try this pineapple. It's supposed to be the most glorious, amazing thing. So I cannot wait to try it. Similar with Arctic apples that just came out a few years ago in 2017. Apples now that don't turn brown when you slice them up. So providing a more healthful food option for children in school systems, where you can actually cut up apples and put them into little baggies ahead of time, and they still have all the nutrition and everything, but they just don't turn brown when the air reacts with that cut flesh. So I won't go into too much detail with all the rest of these, but each of them have a really great scientific story. So if you're interested in learning more, there's a great website called gmoanswers.com that can put you out there. And if you have a question that's not on gmoanswers.com, there's actually independent scientist reviewers out there. You type your question in and they will respond to your question and give you an answer or point you to a website where you might be able to learn more. Okay. And now the fun stuff.
Yeah, absolutely. Great.
Get a mic check here.
Yep, we can hear you. We can't see you though, Ryan.
I have a solution for that,
All right, there we go.
but I gotta figure out how to spotlight myself. Yeah.
I just did that for you.
Okay. Because there's two of me on the call. There's one mobile device where my audio is coming from, but the video looks like we've got it.
Yeah.
Okay, ready to go?
Yes, without further ado, let's get into the good stuff here.
So,
sorry.
This is the fun. Let's do it.
Yeah. All right.
All right,
I'm
so
going to take slides down until you're ready for slides. Does that sound good?
Sure.
Okay.
So my name is Ryan Teller. I'm the automation systems lead here in Marana. I actually got started with Bayer almost 9 years ago in our St. Louis headquarters for North America. I got out of college with a mechanical engineering degree, and since St. Louis was my hometown, I ended up, getting a job interview at this place, and it wasn't a place that I would have expected there to be a lot of automation at, but it turns out that there's a lot of fine-tuned automation needs that are very specific to the process that April was outlining a little bit ago. You can't really buy off the shelf. So we've actually got a in-house engineering team that spans the globe. We've got mechanical engineers, software developers, electrical engineers, technicians. We make custom engineering solutions for those very peculiar applications. So what we've got behind me here, which unfortunately is not running, which is why we have a lot of excellent videos to kind of show you. We have our seeding line. So to do that breeding process effectively, again, that April was describing, we have to be able to track each of our seeds from the point they get to our facility to the point where they get harvested, and we take the seeds off for the next round of planting. One way we're able to do that here in Marana is to use this custom seeding machine. We call it the Assured Identity Seeder. And what it allows us to do is bring seeds in a shoot, I should have had one of these sitting around. 1 second. I do believe that we'll see it better in the video, but in my hand, you can see most of our seeds arrive in kind of this clear plastic cartridge with 24 seeds in there. That's barcoded, so we're able to load that into our machine. The machine will scan it, and then we'll remove each seed one by one and place them into we call a germination tray, like you might see at Home Depot, or you might buy marigolds or something in it. So maybe right now I'll have Stephanie kick off the video for that so we can see it kind of in more detail, and I'll talk through it again. So is the audio coming?
This one has no audio. This one is just subtitled.
All right, perfect. Is behind me right now. You can see the operators loading up a stack of those plates of seeds. It's like it's kind of in slow motion a little bit. So again, this machine is one that was completely developed by Bayer in that last frame. That's a germination tray, so just filled with soil. Gets a little divot so that the seed has a place to fall into. And now it enters our custom machine where you can see the seeds get deposited one by one into the tray. It's worth noting there's a lot.
Uh-oh, we've lost your audio there, Ryan, or at least I have.
Yeah, me too, Stephanie.
See, maybe.
Much more critical, so.
Okay. Okay, we got you now.
Oh, did we lose me?
We did. But you're up now.
Am I still lost? Oh, great. Well,
No,
the part that you missed was all the best parts of the tour, actually. All my best words. But if you're able to see the video, that's the end of the planting process. So the plants have gotten a nice bath of water, and they're ready to do the germination step.
Perfect.
So I know we don't have a ton of time, so I'll wheel us over to the next part of the process.
Hey Ryan, can we ask a question real quick?
Yeah, go ahead.
So our students do this, right? We've got trays and we load seeds into trays and we moisten it and all that kind of stuff. Why does that need to be automated?
It needs to be automated primarily for our purposes is to track the individual seed identity. So we do have ways we can, invert that plate that you saw and kind of do like a scan to match, but it's really hard to know exactly where the seed came from and where it went. So that's problem number one, which makes us spend a lot of money and development time on automated equipment like that. Second reason is we have a lot of different varieties here. So even though all this corn looks the same, we grow it for all different regions of the world, different soil conditions, different environmental conditions, different day lengths. So that means that we need to have a very predictable performance. So by having an automated deposition of seed in the trays and very uniform watering, it removes as much variability as we can from the system. There's always going to be variability from the seed itself, but by removing as much as we can, it makes our jobs easier throughout the entire growing cycle. All right, we'll do a quick pit stop in here. Kind of hard to see with the lights, but for the next 7 days or so after planting, the seedlings will reside in a germination room such as this. You can see a few of them. I'm not sure how well it's coming through. The video might be helpful to look at instead, but like I said, for about 7 days they germinate in these trays till they're about 3 inches tall or so. At that point, they're ready to be put into the vessels they're going to live the rest of their life in. And there you can kind of see that time lapse of them growing in the video, which is pretty cool. All right, and I apologize for giving you a kind of speed tour here. So the next part of the process, I think the videos that we have are going to be probably even better than standing here because a lot of things are happening. It's hard to get a good camera view. But essentially, after 7 days or so, it's time for those little baby seeds to get plucked out and put into a 2-gallon pot. So you see right there is this machine that's behind me. It fills up these pots with germination or potting media, I guess. Then our Apex automated plant extractor will pick up each of those plants out of the tray and image them, determine if they are large enough, vigorous enough, whatever, to be transplanted into pots. If they meet our criteria, they get moved physically into the pot. You'll see again there's a barcode on each pot that helps us remember where each plant went. And by using robotics to pair those things together, we can ensure that we don't lose track of it. There's a few sorting conveyors where the pots you might have saw come out in the video. We have a great time lapse that we can show coming up here. But essentially we use these sorting conveyors to sort the pots out. There, that's a great one. That's a great time lapse. That's looking down from above. So we sort these pots to make sure that we get the two parental plants sitting close to each other on this bench concept. So instead of a field, we create these benches. You can see in the left side of the video. They hold about 54 pots on them. That's essentially our field, except our field can move around, unlike a normal farmer's field. So we build these units of benches. The conveyors sort the plants out to make sure they're getting next to each other, and then away they go out into our greenhouse. I think that one final slide we have shows the crane system. So here we go. So again, pots are coming off of our transplanting robot. This robot's picking them up and putting them onto the bench, like you saw in the time lapse. And then finally, a crane picks them up. So from here onward, you'll notice that it hasn't looked very greenhouse-ish until this point. When they get placed down onto these rolling conveyors out in the greenhouse, now they live the next, 3 months or so out in an actual greenhouse. And before I hand it over to the next person to talk about the greenhouse, any last questions about the early part of the process? No questions? Or do you lose me again?
No questions right now.
Awesome.
Right. Awesome. Thank you so much, Ryan.
Yep.
And we're going to toss it over to the greenhouse now, where Marissa is standing by to show you the beautiful corn.
Hello. Can everybody hear me okay?
Yep, we got you.
All right. So hi, my name is Marissa Labarsky. I'm the agronomic research specialist here in Marana. Specifically, I oversee the growth operations portion of the seed all the way until it's harvested. So you can see behind me all the luxurious corn that we have been growing. I'll go a little bit into my background a little bit. So I've been with Bayer Marana, basically doing what I do for almost about 2 years, a little over 2 years. I started here in 2019 as a contractor, and then in July of 2020, I became a full-time ARS, or agronomic research specialist. So what do I do? I oversee everything revolving around the growth of the corn. So that's the climate, that's plant health, that's even the preventative maintenance to run our equipment, and that's fertigation or irrigation for how we water and feed our plants. So I went to Michigan State University. I got a degree in environmental biology. Funny thing, I wasn't actually working with plants or corn. After college, I worked for a fisheries company, the USDS, not a fisheries company, but the fisheries department of USDS. So I wasn't working with plants at all. But in college, I worked in a field crop pathology lab for about a year. And that's kind of how I got introduced to field crops and kind of, growing in greenhouses. And if you would have told me that I'd be doing that back then, I wouldn't have believed you. It's kind of like I stumbled into this job, and it's like the perfect fit. I don't know if anybody else has kind of struggled with what they want to do when they grow up. I had no idea. I just knew that I loved plants and I loved water, which is funny because I live in Arizona. But I get to work with plants and I still get to work with water and work in a greenhouse setting, which is amazing. So I'm going to show a little bit about how we kind of grow the corn and all the pieces of equipment that help us do that. So a little background first. We use a software called Priva. That is our automated software that controls every piece of equipment that you could see in this greenhouse, minus the bench movement system, and I'll go into that a little bit later. But everything from the lighting, the shade, temperature, humidity, our misting system, and our irrigation system, all controlled by our computer. So I could do it remotely, I could do it on site, really flexible. So I'll just give a little overview of the greenhouse itself. I don't know how much you'll be able to see through the camera, but we'll just work our way down from the top. starting outside of the glass, we have a 60% shade curtain up top. That is really useful in the summer when we need to really control the heat in the greenhouse when it's really warm outside. So that takes out a big chunk of the outside heat, outside light, and still allows us to keep a comfortable environment for the plants. Below that, we have our ridge vent system. We have, it's kind of closed right now, so you can't really see it, but that allows us to vent and exhaust either hot, cooled air from the greenhouse, whatever we're in excess of. It has a little bug netting on it to keep unwanted pests and insects out and keep the good stuff in. Right below that, we have our blackout shade. So that is 100% blackout. When we have that closed, no light can escape, which is really good because in the city of Tucson, we have a light pollution ordinance, and we don't want to interfere with that because when the lights are on in the greenhouse and it's dark outside, it's like a giant beacon in the neighborhood that you can see for I think about 10 miles. We found that out the hard way a couple of years ago. But that blackout allows us to also extend our growing period. So we can go beyond sunrise and sunset. So we can give as much light to the corn as it can take, basically. Below that curtain, and sorry, all these curtains are closed right now, or open, so you can't really see anything. But below that shade, we have our 30% shade. That's probably the shade that we use the most in the greenhouse. It lets in a little bit of light, keeps in a little bit of our temperatures and humidity, and lets out a little bit of the heat. So we can kind of use that and be more flexible and not have such a drastic light effects on our plants. So we can give them as much light as possible, but kind of, like I said, keep out that unwanted excess heat. So we utilize most of these, like that curtain in the summer all the time. And then all of these curtains, except the outer shades, we close them at night and open them in the morning, just about at sunset and sunrise. So then below that, this giant box over here with the blue filter, that is one of our air treatment units. That is basically our main air conditioning for the greenhouse. So just like a car's radiator, it has a fan coil on the inside where we run hot or cold water over that fan coil and blows the hot or cold air, depending on if we're heating or cooling. And so we have 8 of these per greenhouse. One half is facing one direction, the other half is facing the opposite direction. So we kind of get that circular air movement across the crop. Below that, we have our HPS slice. That's high pressure sodium. That helps add a little bit of heat when we're heating up in the morning. About 2 degrees, the lights, 2 degrees Celsius, the lights add to the greenhouse. And we can operate them in alternating strings. So we can either have every single light on like you see here, or we can have it in an every other pattern. So we kind of can reduce that amount of light that we're giving to the plants if we want to, if they're getting too much natural light. It's all supplemental, so we can give them as much light as we want. And these are really helpful in the winter months when we're seeing less light naturally from the outside. And like I said before, how we can extend our growing period with the curtains closed. We can extend in the morning and in the evening. Kind of really hard to see, but right basically at the same level as the lights, we have our overhead humidification system. Basically just a row full of misters that we use and spray and burst to keep our humidity at whatever level that we're trying to achieve in the greenhouse. And then I think that brings us down to plant level. So like I said, the bench movement system isn't controlled by my software, that's controlled by a software called ISIL. So what this movement allows us to do is we can move the crop wherever we want between our greenhouses. We have 6 greenhouses on each range, on this range at least. And so as they start to develop, we can grow them. And as they get bigger, they can be handled by people. The benches rotate around and can be pulled up on the workstation so that they're at the same level as the plant itself. For pollinating, we can scout for irrigation, check plant health, check other metrics of plant growth, EC, pH, whatever we're trying to test. And also you'll start to notice, and probably before they were rotating, that this isn't corn. So why do we have these beautiful plants? We're using this as a banker island for IPM, or integrated pest management. So what we do is we grow these banker plants as an alternative food source for pests to kind of detract from aphids or whatever insects are in the greenhouse onto our production crop. And it also looks really pretty. But like Ryan was talking about, however the benches are being set up, sometimes we can't have a full bench of plants. So this also kind of helps manage the climate in the greenhouse, because a full greenhouse performs better than having a bunch of empty benches, hot metal, baking in the sun. So going back to kind of the process, you'll see these little nozzles sticking out. This is how we use our ebb and flood irrigation. Each set of these nozzles sprays directly into the bench. We can control how long we want to run the water for, what fertilizer recipe that we want to add. And each of these benches will fill up for a certain amount of time and then drain in a gutter system below. All of that water is then recirculated and reused back in our central fertigation room, where we have these giant holding tanks, basically, that it collects all the water. We clean it, sanitize it with a UV filter, and it goes back into a clean tank, ready to be used again. So this really mitigates a lot of water waste and is really helpful towards our sustainability goals. So below that, we have another set of our air treatment units. These are called our air and energy units, or just they look like giant air tubes, kind of hard to see. But below, basically, it's just hot or cold air, whatever we're trying to do, cool or heat, and it's just bringing that upward air movement throughout the crop. There are holes in the benches that also allow the air to move through the canopy. Below that, which you definitely can't see, we have some heating pipes. Those are always heating all the time, and it allows hot, just radiant heat to access to warm the root zone of the plants directly. And then lastly, we have a CO2 system that we just recently started using. We have these CO2 tubes that are similar, but in a smaller form to these air tubes, have little holes in them that run the length of the greenhouse, where we could supplement CO2 to kind of boost that photosynthesis action in the plants. And that's basically it. It's a lot, and it's all controlled via a computer. So I could sit at my desk and change the greenhouse settings instantly. Are there any questions?
Well, how about we show pollination really quick, and I'll pull that video up so we can kind of show how the benches of corn will come to the people. Can you speak to that one, Marissa?
Yeah. So basically, like I said, so the benches move in it's almost like a game of Tetris. They just rotate between rows, and they can fill either this whole greenhouse, or they can move across the greenhouses. So how they pull them up with the stick, and then they can actively pollinate them. They'll put the bags over the shoots that are coming out, the ear shoots, bags over the tassels to kind of make sure that pollen is going to what part of the ear that they want it to. And then they'll push it back, and they'll go right into rotation. They do this every morning. And it's also the same, so we could pull benches up. We can scout plants individually, because right now we have to scout basically going between rows. So this way you can see every individual plant up close, and then push it back, and it rotates around like a fun little roller coaster.
I love that Tetris analogy. That's great. And it also looks like ballet choreography, the way they're
a little bit
working. Yeah. Awesome. All right. Well, this concludes our tour for you, but we'd love to take some time for Q&A before we wrap up, if there are questions in the room.
We can throw them in the chat too. Anybody have any questions? Yeah, Jocelyn.
Is it only corn you guys grow, or is it just that?
So the question is, are you only focused on corn? If so, why? And if not, what other plants are you growing?
So our
See.
only production material, oh, sorry, I don't know if you want to
No,
speak on this.
I was just going to say, Marissa, do you want to take that question?
Yeah, so the only crop that we grow specifically to send out to our partners and our customers is corn. But like I said, we'll grow other things just to fill the climate. We've had a couple projects out here just growing random things just to see if we could grow it. It looks like we can for the most part. But mostly just for IPM purposes, we grow inside the greenhouses. And then it's discarded after. Yeah.
It's probably worth noting that, our location here in Marana grows corn, but there are other sites that do a very similar process as us that do cotton, soybeans, wheat, a lot of different crops.
All right. What's the next question? Anybody? I think they're just done. I have a couple, so I'll throw those in. Earlier, Stephanie was talking in her one of her slides had 140 acres, and then it worked its way down and how much more we can produce in a greenhouse, right? So it was however many square feet now was what an acre used to produce in terms of bushels. But like at some point to do that amazing amount of production, like what you guys have going on in your greenhouse, you have to put in a ton of infrastructure and controls and all that kind of stuff, as opposed to a field where, right, especially if you're in a wet climate where you don't even water, where's that payoff? At some point, you're putting in so much money and effort that you're actually costing yourself more, even though with that intense work, you can grow more in a tighter space. And when we're talking about feeding of the 2 billion people, we've got to kind of manage the people resources, the money resources, and soil and water. So it's like where is that crossover point?
I think for corn, it's important to note that the reason that we spend so much money on this facility for growing corn is because of those advantages we get for keeping track of all the different varieties in here for our breeding process. Corn itself is probably not a great candidate for like large scale growing in a greenhouse because it is super expensive and it's a very hardy crop, which makes it great for growing in the field. So for corn specifically, it's probably in the near future not going to hit a spot where it's economically feasible to grow in a greenhouse like on a large scale. My 2 cents.
Yeah, and just want to really add to that as well that our corn is really the corn for a future farmer. We've got several years before the corn we're growing today gets into a bag of seed for that farmer. And so we're pretty early in that research and development process of the seeds that we hope to get to farmers. And ultimately we're trying to get there faster, but it's definitely up to 10 years depending upon what we're working on. So we are, I want to say, just a couple of years away though from our first seeds becoming commercial. And April or Ryan could maybe confirm that for me. I think we're pretty close.
Yeah, that's true, Stephanie. So sometimes the product life cycle on these corn varieties can be 7 to 10 years, just of all the R&D and all of the commercial testing that needs to go in to really make sure that we're giving something not only that's going to yield well and perform well, but that's also going to be safe for the consumer.
Great, thank you. I got one other question. This is for Dr. April. She was talking about the USDA study with the trillion data points about no organism that we know of has suffered from eating genetically modified foods. But recently, like a year or so ago, there was the court case on glyphosate and cancer. And while all the science very clearly says that glyphosate doesn't cause cancer, that court case and the jury trial still awarded damages to the plaintiffs. So like, even though the science is very clear, we still have a societal problem. So like, how do we get past that?
Well, that is a fabulous question. I think, I mean, as scientists, I think we go out, and yourself included, we want to see the data, and we want to make our case known, not as an emotional argument, but as to say, this is an objective fact. Here's, what the science indicates, with numbers and numbers and numbers of studies. But it's really hard to counter an emotional argument with science, and that's where I think scientists have fallen short, and why it's incredibly valuable to have people that are professional communicators like Stephanie Bowe, who can help us to kind of talk through not so much just these are the trillion data points. People can't even really get their heads around how big a trillion is and what that might mean to them. All they know is that genetically modified organism sounds like something scary, and that there's a lot of marketing out there that says it is bad. And so really trying to connect with people on a personal level and to understand what it is exactly that they're concerned about, and that maybe those concerns really are just emotional, and that's okay. If someone has a right to have an emotional choice about their food and what they put in their body. But if there is a scientific bit to it, to say, well, I heard that glyphosate causes cancer, and it must be true if a jury awarded it, so the science must be there, I just don't know all the facts. That's when a scientist can really connect and say, what, that's actually not true. The jury really did make an emotional decision, and that jury trials a lot of times don't align with science, because really it is regular people who don't have scientific backgrounds that get swayed by really persuasive arguments that really make that burden of proof hard to overcome for them.
Great, thank you.
Did you want to add to that? I would love your pointers if you have ideas about how to help with that. I think people like yourself getting your students educated too is really, really the way of the future.
Yeah, I think it's just going to take beating the drum for a long time, and obviously the last 18 months is not helping the testimony of scientists. So it actually just got stupider. So if that was believable, but there it is. So does anybody else have any questions? Obviously you're in a research facility, so you don't have a lot of live tours, which is why you guys have worked so hard on your digital tour skills. And then the COVID happened too. Where else are other Bayer facilities happening? Is it mostly for the pharmaceutical bit, or is it just crop science also?
So, Stephanie, maybe you can speak to the size of the divisions, but I'm pretty limited just in my knowledge of crop science, but we have sites all over the world. And so Bayer is a huge company. There's over 100,000 employees worldwide. A lot of those are in manufacturing areas, so not just manufacturing, say, the aspirin factory or the Claritin factory, but you also have crop factories that are field sites that produce seed for farmers to grow, that we then sell, similar to how we would sell a blister pack of Claritin at a pharmacy. We also sell bags of seed through seed dealers that then can be purchased by farmers to plant in their fields. So, but R&D, we have the largest R&D component of any crop science company, or at least of the major ones. So we invest more of our profits in R&D year over year. And so what that means is we're the largest. We have the #1 market share in the eight biggest crops. And so as we're the #1 market share and we have more profit coming in or more income, then we're investing a greater percent of that income year over year. And so our investment in R&D is actually growing, in a much larger ratio than the competitors because they're investing a smaller percent and making less. So we're even pulling ahead each year with that. So it's and I've worked for the competition. It is a very different thing to be in a startup than to be in a big company like Bayer. And part of what I really enjoy about being with a big company like Bayer is that I get to work with experts like Marissa and Ryan, who have really different technical background than I do, but that means that they can identify a lot of problems that I don't even see, and then have them halfway solved before I even know that I needed something. Which happens with Ryan. I feel like we share half a brain sometimes, that he's already got solutions to problems I'm just discovering I had. So it's really great.
Yeah, and I did want to just say that before COVID, one of the things that we were most looking forward to was having the in-person tours through the facility. And, COVID just kind of threw a monkey wrench into our plans. But we quickly shifted to this virtual format because, it is really important that we're transparent in the work that we do, even though we are in that research part of the company. Because again, if we go back to that GMO conversation, the vaccine conversation, if we aren't talking, people are making up a story about what it is that we're doing. And so, from my point of view, things like this is the most important work we can be doing in order to make sure that we can continue to do what we're doing. And it's vital that we tell our story, to you. So hopefully when someone says to you, they're making GMOs in Marana and it's horrible, you can actually say, oh no, I've actually seen it and it's incredible and they're doing great things. So we have tours in Chesterfield in the St. Louis area of our main headquarters. We're working on a program for our Hawaii sites to do some virtual tours because honestly, I don't see our company opening our doors for in-person anytime soon. And so we have to use this technology that everyone is used to now. And I mean, our new camera that Marissa was using today was zooming right in to show everything. And we've really iterated over the last, 18 months on using different cameras and different methods to show the best that we can through these digital platforms. But again, like we've got to tell the story, and I believe wholeheartedly that that's where we went wrong back in the 90s when GMOs first came on the scene. And how do we do better when we're thinking about new technologies? It's storytelling. It's telling from the heart why we believe in these things. And that's at the end of the day what's going to help move the needle for science.
Well, I sure appreciate this opportunity. I think the virtual thing actually has some benefits in that we didn't have to get a bus and drive for, an hour and a half to get down there and then, feed them lunch and all that kind of stuff where we just open up our classroom and we're here. That's a big part. There was Dr. Berg. He was a researcher at the University of California. He actually made a comment in a video series we watch in our class called DNA from PBS. But anyway, his comment was that most of our early genetic modifications and even a lot of the ones you guys are doing are all aimed at the production side. So they benefit the producer, they benefit the farmer, they benefit the seed company, and they don't really help the consumer much, right? It's not like some of the niche things, right? Like the boutique watermelons and that kind of stuff help a consumer, but like just because the corn grew in a drier condition with less water, right? That doesn't help me. I still just want to eat the corn. And so part of our problem as agriculturists is we're making a better product. We're making it so we can grow in wilder conditions. We're increasing our ability to feed those extra 2 billion people, but the consumer just sees a piece of corn that looks not much different than the other piece of corn right next to it. And so they don't understand, like, why are we monkeying with all this if we're not really changing anything? So that's part of our story problem. So nobody with any questions? Oh, go ahead.
Oh, I was just going to say, I'm going to pull up one more slide that talks about, why corn a little bit more too, because that is something I'm really trying to evangelize a little bit, is that corn is in everything that we touch in our daily lives, and we just don't know it. And so to your point, that is something we need to talk about more, that if there's carpet on the floor in your classroom right now, there is a component of corn under your feet. If you wash your clothes in Tide and dried them in the dryer with a bounce dryer sheet, components of corn are in those items. And as well, Halloween, we had corn syrup in probably every piece of candy that we ate. And so it is in our daily lives. It's part of everything that we do. And corn is really that, number one crop pretty much. And it's not just biofuels or feed for animals, it's really a daily part of our lives. Even the outside of a Bayer aspirin has a component of corn. That shiny outer coating that helps you swallow a pill is a component of corn. So that is my new favorite thing to talk about.
All right. Well, thank you very much. I guess we're good. So I'll shoot you a couple emails, Stephanie, and thank you to everyone else who was here online with us, and you gave up part of your morning for our students here. Thank you.
Thank you.
You're welcome. Thanks so much for joining us today.
All right.